our friends at Anthropic dropped a bombshell that is not getting enough attention. So two actual papers were dropped on this, but circuit tracing.
Yes.
Why is this such a big deal, and why do so few people seem excited about it?
Yeah. Well, if you go into the meat of it, right, deep learning, building these large language models, AI is like, we've been in this space for a while. Like I've personally worked on this problem for like 8 years, which is, trust me, in AI ages.
Yeah.
Right. And the biggest problem with GANs was, apart from the fact that you can't train them, or with the models, like
the list is long.
It's a very long list. But the biggest problem with neural network based models in general, AI models, was that you have literally no observability into the inner workings of the model.
Yeah.
Right. So if you think about how a large language models reasons, right?
Yeah.
Like there are a lot of studies on whether it actually reasons. Like Apple recently put out a paper that actually says like they're not as good at reasoning as you think.
Apple's trying to be like, AI is not happening.
Yeah, it's not happening.
Even their research is
like, just like they slow burn the features. They're like, we're slow burning this.
Yeah.
But the point is not that, right? The point is that it's no one really knows how models actually work. Even if you have a PhD in that specific space, no PhD claims that they know everything. Like that is a wildly held truth. So when you don't know how it works, it's really hard for you to design models that do exactly what you want them to do, right? And that has been like an age-old problem. And there have been many ways to circumvent that problem. Like for example, during inferencing, people have been hooking up to the models and trying to understand what neurons are firing and to try and predict what kind of a mode the model goes into, right? But even then, people haven't really been able to crack which parameter represents what. So when you build models, it has been always like experimental. Okay, let's change the value of parameter alpha to X and then see what happens. Like, does it train better? Does it run better? If it does, let's move in that direction, right? So just like gradient descent, historically, the algorithm is like, let's move in the direction of converging. Like that's literally how even building models had been going. But what Anthropic has done with circuit tracing is they've released this library, which essentially enables you to have a GUI-based representation graphically that demonstrates which circuits and or nodes. So circuits are like groups of nodes, and a neural network model can be thought of as a set of chained nodes, right? That's a classical deep learning based representation of models. So that they let you visualize which nodes are firing, right? Now this may not seem phenomenal at a first glance because you've had the ability to do that in deep learning, but the fact that you can now apply it to much larger language models and you can do that at scale and you have this consistent representation is super helpful, because it's going to reground the community's attention and enable researchers who otherwise did not have access to such frameworks to be able to use them and build better models, right? And if you think about the implications, you're going to be able to understand which set of circuits are being triggered for which specific use case. And you can go a lot deeper and build entire solutions around it, where you can try to study hallucination, probably predict it. You can have implications on the model's security, right? Where you can build more secure models just because you've controlled and you understand the paths that a model works through. So even though they've not solved for complete model explainability, they've really enabled the industry to start catching up in this space.
And they've seen this kind of multi-step reasoning path happening inside the models, both small and big, which was a believed approach, right? But not a certainty. Right. And so why does this matter?
I think this matters because if you look at what the barriers are to trusting a model, right? Like the real barrier for enterprise adoption and for this like going into more critical and more interesting use cases is trust. And it's really hard to trust a model and even today, like in many complicated use cases that involve human safety, we can clearly say that you should not be using a large language model for that use case. But the further along we delay this implementation, right? The ability, just because there's more regulatory control needed, that's more implications for human safety and so on. The further along you delay testing and adoption for those use cases, you're pushing those industries back, right? Because AI, let's get it, in many cases, the effect of using AI far exceeds what humans can do on a standalone basis, right? Just because models are not constrained from a speed standpoint, from a memory standpoint, and they're able to reliably mimic and exceed human performance. We've seen that many times, be it like in games, be it like playing things like AlphaGo, be it like even in code generation, in many use cases. So we know for a fact that we can get AI models to be better than humans. It may not be there every day, but those use cases are important. So for us to be able to deploy models, they need to meet some basic safety criteria. And the number one factor when regulators build policies around these things is control and observability. Like how can I, like even if you think about the self-driving use case, right? At some point, Waymo, Tesla, they included the ability for you to see what the vehicle is doing next. And the reason for that is for you to have potentially a chance to intercept and protect the user, right? So I think that's the direction this is headed in. And the added safety and control, once the community achieves it, will unlock unprecedented progress.
I found one of their examples very interesting, where they asked two different size models a similar question. They asked a relatively simple question, something around the lines of the state of, there's a state that has the city of Dallas in it, in which has a capital, which is, right? So it's like, forces somebody to do, like, even in your own head, you're like doing the multi-step reasoning, and the circuit tracing path in the small model and the big model looked almost the same, right? And so you can say, okay, so for this type of constrained problem, I'm actually not going to get any marginal gains from making the model bigger, right? But you can see where there's differences in the multi-step reasoning for a much harder problem between the smaller model and the bigger model. And you can say, what am I going to incrementally improve on in the next model size? And you can directionally say, this is worth it to go bigger.
Yes, exactly. And you have, a number of techniques that let you benefit from a larger model as a smaller model. Like you have distillation for a while, where you have like a student model and a teacher model, and you distill the parameters from the teacher model onto the student model, right? And once you've identified, like, it's, let's be clear, if you have a smaller model, it's going to be much cheaper to run. Right? And if your use case is narrow, you're wasting compute by using a larger model. Right? It's just heavier and more costly. And it's also faster to have the smaller model. So now that you have this, it's not just intuition, or you're not limited by the evals you run to be able to tell you whether or not the small model suffices. You also have the added reference of this tool that can tell you exactly the circuits that need to be triggered to solve that use case.
You can have confidence that, like, if my problem is of this sort of problem, then I'm fine at this model level. Versus what's happening right now is people are like, well, I'm just going to take the incremental cost of using the bigger model because, sure, I've done some evals, but I don't know if they're robust enough. So I don't know what's going on underneath the hood. So therefore, I'm just going to use the largest model, incur the cost, and then pass that on to the customer somehow, or use equity dollars to subsidize until prices go down. So like, that is a huge waste to the system that now can be solved for.
Exactly, and you now know you can make more informed decisions when you're distilling model parameters, right? Because you know the circuits that are relevant to you, so you can accurately decide if you even need the model, and then how do you improve the small model such that you can use that to replace the large model.
So what is the advantages for the application developers, people building on top of these models, leveraging these models, versus the model developers themselves?
Well, I think if you're more often than not, like if you're building on a closed source model, you're not going to be able to use these tools, right? But what we've seen from the application developer's standpoint, like if you consider any of the tools out there, let's take Cursor and Windsurf for an example, just because they're more relevant to us. We track them more closely, and they both have their own models, right? And they use that as the primary and the Anthropic, the Gemini, and the other models, they're really secondary. And the reason I say that is because that's their default setting, right, in their UI. So for them, being able to understand and unlock the next level for training better models is highly reliant on this, right? Because they want to build the smallest possible model that creates an optimal experience for the user, right? So as an application developer, they don't have any insight into the closed source model, so there's nothing they can do about that, but they can run the same use case across two different models, right? And one of them being their control variable or their own model, and they can see potentially what led to the flawed output, if any, right? And they can run more effective experiments to improve that and get to a better outcome.
Yeah. Do you think this will cause more people to get into developing their own SLMs?
That's a very interesting question. I think there's, the challenge really is the rate of performance improvement in the larger models, and at the same time cost reduction has been unprecedented. So
it's a hard time to be in the make your own model game.
Yes, exactly. Like between 3.7 Sonnet and 4 Sonnet, the price was unchanged, but it had like a 5 to 10 percentage point increase on SWE-bench, and SWE-bench is hardly a reliable factor of of quality. Like there are tons of other use cases where it's very, very clear that Sonnet 4 is a much better model than 3.7. But the price was unchanged. Right. So the performance to dollar ratio was altered significantly, and that will apply to even their smaller models. So even Anthropic makes smaller models, right? And they're essentially using. So the way it works on any model maker side is that their largest model eventually becomes like the flagstick for everything else, right? So if they make Sonnet, it's more likely to be like a lesser version of Opus than to be a completely new model, right? And then correspondingly, the Haiku or the smaller models, they're more likely to be a lesser version of Sonnet than to be a completely different model, right? So as that shifts, it is really hard for you to make like a reliable, smaller model and keep updating that and beat the labs at it. But that may not be the case perpetually, right? I think we're at a point where there are significant gains from test time inference. We might have, significantly slowed down the pre-training aspect of it, which is why we're seeing a slower release from GPT-4 to GPT-5 and from Claude 3 Opus to Claude 4 Opus. But we're seeing significant leeway and significant scope for gains to be made in test time inference, right? But there might be a new aspect of it as we come to the end of test time inference. There's test time training and test time fine tuning, which we really haven't even scratched the surface of. And that might change the dynamics a little bit.
That's like the next net new exponential after this exponential is explored for test time.
Yes. And it's hard to really predict what would be the driving factor there without having seen much of it, right? But I think if, for example, it's more about how much compute you have and how much you're able to deploy dynamically, then if you're a model maker and if you have the ability to fine-tune models, you're a winner, right? Because it's hard for the labs to have a monopoly over compute, although they already have like a ton of dollars that they can put into this and get ahead of that. So this unfortunately is a problem that you can solve with money, so it's likely that they will solve it. But if there are specific use cases, when you combine this with the fact that you now have tools like the circuit tracer, then you can make incrementally better models for your specific use case if you have a small amount of additional compute. And that is what the game changer is going to be, right? So if you get on this wave, if you start improving your models, then by the time you have test time fine-tuning or test time training, you have an edge that you created for yourself.
And I think few folks would say their use case right now would not improve by increased intelligence. But we're not that far away from that reality being true, where there's a number of applications that say the models today are sufficient, they're good enough for exactly what I'm trying to achieve within my application, Therefore, the next incremental advance, like it's not going to add to the consumer experience or the business experience to what I am delivering within my widget, right? Like probably not true for customer support, probably very true for some document processing use cases in the next 12, 24 months where it's going to be, hey, this is sufficiently accurate, right?
Yep.
That's when we can say, okay, great. Like we will now go down the path of our own models, right?
Yep.
Because then cost reduction becomes really, really important.
Yeah, and I also think that even if there might be an understanding that your specific use case is not really benefited from more intelligence, I would say that is super rare.
Yeah.
Just because it's not just intelligence that moves the needle, right, every single time. What happens also is that cost goes down.
Yeah.
As models get more intelligent, the labs are sort of, there's like a forcing function that lets you, because it's competitive,
Yeah.
right, lets you drive down the cost. So the cost per intelligence, right, the intelligence per unit dollar is constantly going down. So even if you may not be benefited by the increased intelligence, it's now costing you lower.
Right.
And because it's more intelligent, if you decide to not go to the lower tier and stay at the higher intelligence level tier, from a cost per dollar standpoint, then you have to do fewer validations. Because if you're not benefiting incrementally by intelligence, you probably have very strong validations in place that lets you do this. But then maybe you don't have to rely on them as much just because the models are that much better.
Yeah, and so it'll really be this like trade-off of like, do I use GPT-7, right, in a single pass, or do I use Llama 5 distilled, fine-tuned, maybe 10 times, right, within my system, and if that is cheaper and equivalent to GPT-7, then I might use Llama 5, right? But this is like, obviously none of these things exist, right? Like, and so this is like how the field maybe could play out at the application layer.
Yeah, you have quite a few significant advantages, right? Like if you're like, if you're like a financial services firm, like you should probably stick to using the state of the art.
Yeah.
You should not even think about this. Because just like there's a cost of specialization, right? But if you're...
I have to admit, so I listened to Bill Gurley's Invest Like the Best this morning on my walk to work, and he was just harping on me, I felt like he was talking to me, where he was like, you know, he's talking about cursors and stuff. He's like, none of them care about unit economics right now. But they need to be thinking 3 or 4 years out, like, what is the plan for unit economics? And so I'm coming in with a plan for these guys to use Llama 5, but please go ahead. I hear you, Bill.
Exactly. Yeah, no, there's a significant advantage you can get if you're able to use Llama 5.
Yeah.
And that advantage is that...
It isn't here yet.
And that, which, let's say Llama 4 or Llama 3, like, the advantage is that you're able to use tools like circuit tracing. And you're able to see where they're not good enough, right? And you're able to fine tune more effectively. You're able to distill more effectively.
Yeah.
So that's the trade-off. Like if you have the time, talent, resources to dedicate to that endeavor, and it's going to be significantly expensive. You need GPU allocation, and there are firms in the world that can definitely spend a lot of time on that and get a lot of value from that. So if that is worth it, now is the time to do it.
Okay. And what does it mean for Blitzy?
I think for Blitzy, we're long term, it is definitely our goal to have our own models, and we're working on that as we speak. But what we're seeing at the moment is that there is a cost of fine tuning, and I'm not talking about the financial cost. I'm talking about the cost of performance. So when you fine tune for a narrow use case, what happens is that you lose the ability to generalize. Right, so you might have a model, for example, that is better at UI, but it's not going to be as good as backend. And given the nature of UI, where it is like there are full stack engineers who do TypeScript, and you can use Node.js in JavaScript/TypeScript, right? So now you have a problem there. So it's really hard to fine tune and get it to do better than the state of the art models, which is why anything on SweBench, any model that does really well on code generation, it is highly likely, though not always true, it is highly likely they are actually under the hood probably using some version of Claude with either scaffolding or a combination of multiple versions. Right. So the point is that it's really hard to beat the major labs at the moment because test time inference still is a thing. So we want to continue to ride that wave. But having said that, given that we know what's coming, we're preparing ourselves for that. And we also will be having our own models.
And it's likely that our system design will be leveraging some amount of state-of-the-art models, just like we do, and some amount of our own fine-tuned models.
Yes.
And we have the ability to call one, and if our own version fails, we can call the other one, which is like the whole point of having multi-agent orchestration dynamically.
Exactly. If you think about the architecture for Blitzy and the kind of customers we have, some of our customers do not want to have their data sent to OpenAI or Anthropic. And it's not about OpenAI or Anthropic. It's just that they do not want to send their data over the internet to anyone.
Yeah.
So they need an on-premise deployment in some cases, like literally on-prem. In most cases, a virtual private cloud deployment that is cut off from the internet. So there's two options there. But we want to be able to meet the customers where they are rather than have them make broader technical decisions or compliance decisions. So for that, we absolutely need to have our own models. So we have like early versions, and they're definitely not better than something like a Claude. So that is the trade-off that customers have to make today. But the way we see it is that going forward, as this space stabilizes, we will be able to provide those customers a comparable experience, if not on par with the current generation of models, at least with the previous generation of models.
And the customer is well positioned to make the trade-off on if they do or do not want any internet access for their system, then they're still going to have incredible gains with, Blitzy, we're using all open source models, which is a deployment option, versus the standard option, which uses all the state of the art in some combination.
Exactly.
Cool. It's been a fun one, man. Circuit tracing, underrated.